tomorrow you're going to do the assignment. Thursday, Friday, I'll do 9-2 and 9-3. Okay. We have done this already. We did it in applied. It's just shading regions. Okay. The only difference is the parabola. We didn't look at a lot of the parabola in the applied. And then starting next week, probably Monday, you can start studying for your exam. So 5 days next week means that you have 5 sections, probably one a day that you can look at, going through assessments, go through the ones that are important to you. And then you'll have a day or two the following week to study for that. There are exam questions there. I did put the format for the exam, like what the mark breakdown of the exam is also there. So I'll give that to you today. But for the most part, we'll just we'll get into your assessments and look at those. Okay. All right. Basically, and again, if Desmos to help you with this today. So 4x minus 3y is less than -12. Okay, so let's talk about how to graph this. Okay, now I look at those 3 coefficients right now. What do you recognize about those 3 coefficients? Anything, how you can tie them together? Yeah, okay, perfect. They all go into 12. All right, so because they all go into 12, I would approach this by graphing using my intercepts. Okay, so the first thing that I do when in any one of these questions is I convert this to an equality to figure out how to graph the line itself. Okay, so let's put 0 in for x. So I put 0 in for x. That means I have minus 3y equals 12. Negative 12. Thank you. What does y equal? What is it? 4. Okay. If I put 0 in for y here, I get 4x equals -12. What does x equal? -3. Okay. So I go to 0 and 4. I go to -3 and 0. Now, solid or dashed line? How come? Because there's no equals to on this. So it's a dashed line here. So I do that. Okay. And finally, I need to know which area to shade. How do I determine which area to shade? Yeah, it doesn't have to be 0 and 0, but it makes the math easy, right? So is 0 less than -12? No? Okay. So then 0 and 0 is not a part of the shaded region. So this is my shaded region up here. We remember this? Yes? Okay. Was it 4x minus 3y is less than -12? All right, so there you have it. Okay, so as long as you can graph a line, you can shade the region. The other way to graph a line, of course, is to get it y equals mx plus b. Let's look at the next one here. Excuse me. So I have 2x minus 3y is greater than or equal to 15. Okay. So first step is to change to an equality. 2x minus 3y equals 15. Minus 3y equals -2x. Add 15. So I subtracted 2x to both sides. I divide by -3. Y is equal to 2/3 x subtract 5. Okay, so I divide by -3 to get y by itself. What is my starting point? Zero and -5. 1, 2, 3, 4, -5. Where do I go from 0 and -5? Up to rate 3. Solid line, yay?
Yeah.
Because of the equals to? Is 0 greater than 15? No. So when I put 0 in here, that gives me 0. 0 in here, that gives me 0. 0 is not greater than or equal to 15. So the shaded region is down here. Are we okay with this? Yeah? Okay. So the only the only part that might cause a little bit of difficulty is when you're not given the equation, you have to write it out yourself. So let's have a quick look at one of those. I may even go into 9.2, just because we don't really need to rehash this too much. Sports equipment manufacturer makes footballs and soccer balls. One football requires 4 minutes on the cutting machine, while one soccer ball requires only 3 minutes on the cutting machine. Determine an inequality that would represent this situation. Draw a graph of the inequality to show that the number of each type of ball that could be made in 30 minutes or less. Okay, so if you recall, we went through defining, and then constraints, and then restrictions, and then the objective. We don't have to do all of that. So the defining part is, what are we going to define here? What are the two unknowns that we have there? X is going to equal what? How many footballs, right? Y is going to be how many soccer balls? And we're doing this all based off of the time. So for one football, how long does it take to make? 4 minutes. So I have 4x, add 3y, and it has to be less than or equal to 30. And then graph it. Again, use Desmos if you need to make that work quickly. Okay? Anybody concerned about this? That I need to do more with it? All right.
You don't have to like write out all those things.
No. No, you don't. You just have to shade. And there's a lot of work in there, but you don't need to. Okay.
So like for the word problems, you still have to use like dots and everything. Because, like,
Yes.
a little hole.
Yeah, you would. And this would be a case that you would, okay, actually good point. Let's do that. Okay, so to graph this one, I'm going to change it to 3y. Sorry. 4x. 4x add 3y equals 30. 3y equals -4x, add 30. Y is equal to -4 over 3x, add 10. Okay. So what is my starting point? 0 and 10. Where do I go from there?
Down 4.
Solid, eh?
The negative will only apply to like one number on the fraction.
Yep.
So like, how do you know that?
What do you mean, how do I know?
Like whichever one the negative's on before.
What is
So like if it's negative. should
what
be
is -4 divided by 2? What is 2 divided by negative? Sorry, what is 4 divided by -2? Same thing, right? Right. So it doesn't matter where I put the negative, top or bottom.
But then like your graph, if you go the other direction and then the other direction.
Ah.
No, because if you go.
All right, so let's change
Up,
4 over negative 3. Now where do I go? Up 4, left 3. I still hit the line.
Oh, it just goes the other way.
Okay? You have to apply it to one of them. You have to apply it to one of them. So either you go up and, in this case, you would go up and left, or you go down and right. It'll still hit the line. Okay, now, put 0 and 0 in. 0 is less than 30, eh? So then I have to do this. Again, why am I doing this? Because I can't have a part of a football or a part of a soccer ball. So in that case, I would have just that. And notice I also only do first quadrant, right? Because I can't have negatives either. So you do have to, when you do the word problems, you do have to pay attention to that. Now, you don't need to write all of the other stuff out, but you do have to understand that it's whole numbers only for that.
So it's only the shading and the dots, not the shading and the dots together.
Yeah, which one's like the shading and the dots?
I don't remember that. I do, it was just price and item, wasn't it?
Yeah, like you had to dot it and shade it.
Yeah.
No, I don't. I don't remember. I thought it was just one or the other. I don't remember ever doing it.
Just do one.
Both.
I thought there was one way to do both.
Okay. I don't recall that, but
We're probably
If it comes
wrong
up-
then.
if it comes up, we'll look at it. Okay, so let's look at quadratic inequalities in one variable. All right, so in one variable means that we don't have y, which means that we are only using a horizontal number line. Okay, so let's start on page 380. And I'll make this all go quickly. Okay, so the equation is x squared add x is greater than 6. So there's my equation. Now that means then that there is no y involved, which means I don't have a vertical axis here. I'm only dealing with the horizontal axis. It's actually pretty easy at that point. Okay, so the first thing that I'm going to do, again, change this into an equals, okay? So x squared add x minus 6 equals 0. So I subtracted 6. Now you have a quadratic. We always make it equal to 0. Then what do we try and do? Factor it. So let's factor this. X and x, right? What are the factors of negative 6 that add to give me plus 1? Plus 3, negative 2. Very good. So that means that my x-intercepts would be negative 3 and 2. So now I need to find out what part of the number line does this graph satisfy? And then I have to explain it. Okay? So all I do is this. Draw my number line. Okay. Now, on the number line, what I'm going to do is where my intercepts are, I'm just going to draw a line here. Well, it's kind of a dotted line. Here and here. So far, so good? Now remember, I'm trying to find the shaded area of this. All right, so I'm going to follow the steps on this page just so that I don't miss anything. Rewrite the inequality so that the quadratic expression is on the left side and a 0 is on the right side. We've done that. Sketch the graph of the quadratic, labeling all intercepts and the vertex. Well, we didn't do the vertex yet. Highlight the section of the x-axis where, okay. All right, I'm going to kind of do this a little bit different than the book. So now what I want to do is I want to find out, again, I am working with shaded regions because it's an inequality. So I want to see what part of the graph should be in the shaded area. But instead of doing the shaded area, what I'm going to do is I have to draw a line or arrows to show what's correct. So the first thing that I do is I check this region right here. And I do that by putting in a value. So I'm going to start with 0 to see if it makes it true. So I've got 0 squared plus 0 is 0. Is 0 greater than 6? No. So this is not part of the shaded region. So I just put an X in there. Now I'm going to put -4 in there. -4 squared is 16. 16 subtract 4 is 12. Is 12 greater than 6? Yeah. So I'm going to put a check mark here. Now I'm going to use 3 over here. 3 squared is 9. 9 plus 3 is 12. 12 is greater than 6. So it works here. Okay. So I noticed then that any value to the left of -3 and to the right of +2 is going to work for us. So my solution would look like this. I would draw an open dot here, because it's not equal to, and draw that, and then an open dot here, and draw that. So to write out my solution, x such that x is greater than -3, x is less than, no, sorry, x is less than -3, my bad. X is less than -3, x is greater than 2. X is an element of all reals. There's your solution for that question. So in this case, because I'm not drawing the graph and shading it, I am going to write it out based off of my domain, my x values.
So remember, like, we aren't gonna shade gravel.
Not yet. Not in one variable. In 2 variables, when we have the y, then we shade them. But what we learn now is we learn how to find the shaded region part right now as 1 variable, and then we switch it over to 2 variables. Okay? So let's look at the next one here. I have 2x squared plus 5x less than or equal to 3. Okay. Change it. 2x squared, add 5x minus 3 equals 0. Okay. For some of you, it's going to be more work than others. If you can do 2 sets of brackets and factor this, awesome. Some of you might need to do the product sum whole thing. Okay, so let me do that first. All right, so what's the product here? -6. That's A times C. The sum is +5. Therefore, the factors are what? 6 and -1. So 2x squared minus x plus 6x minus 3 equals 0. X, 2x minus 1, plus 3, 2x minus 1, equals 0. X add 3 times 2x minus 1 equals 0. Okay. There's my x-intercepts. Any issues? I know this has been a bit of a problem. this factoring. But you can see we've been doing it since grade 10, how much factoring was involved, and we do it again in grade 12. We do a lot more factoring. Okay, so let's go through the question then. Number line, 0, 1, 2, -1, -2, -3. -4. Okay. So I mark off again. Just mark off on my number line where my intercepts are. All right, let's put 0 in. 0 plus 0 is 0 less than 3. Yeah? Good for that section. Now I put 2 in. 2 squared is 4. 4 times 2 is 8. 8 plus 10 is 18. This is not going to work. Put -4 in. -4 squared is 16. 16 times 2 is 32. 32 subtract 20 is 12. 12 is not less than. So there's that. Okay. So now I want to indicate on my number line where it works. Solid or closed or open dot? Solid to there. X such that -3 less than equal to x less than equal to 1/2. X is an element of all reals. Always start left to right. Okay?
So when you're running the solution, like, can you write it in 2 different ones like you did last time, how you did like?
Yeah, you could go x is greater than -3, comma, x is less than 1/2. It doesn't matter. No, it's still okay to do it that way. Okay, any issues? All right, so I just do want to show you this though. If you were to graph this on Desmos, so that equation was 2x squared plus 5x less than or equal to 3, right? So you see what happens here? Is it just shades in between there like that? Okay, but we don't really have a parabola there, do we? Because there's no y equals, so it's just using that number line to do it. Then in 9.3 we do the actual parabola. All right. Okay, so that's that. So take some time today, do a few lines on this, like to where you feel comfortable, and then do a couple of the like 6, 7, 8 somewhere in there. Do a couple of those questions, and then kind of get into 9.2 a bit. All right. Again, we won't assess on this, but it will be on your exam. You had a question?
Do question 7 on problem and the extra questions, like, in 8.
Just a second here. I'm gonna do this. All right, now, do I have that anywhere? I don't know if I have a copy.
paper.
I don't think I got an extra copy. Okay. The sum of the reciprocals of two numbers is 4. 1 over x plus 1 over y is equal to 4. Four times the product of the reciprocals. It's a little more complicated than what we need for this section. Yeah, I think we're just, you could follow it through, but I don't think you need to do that. That seems a little bit excessive for what we did this week. I mean, you would have to get a common denominator, should be x, y. So you get y add x equals 4xy here. So that presents an issue. I think you would have to, my thoughts are you'd have to like this, factor out a y. And then you'd have to substitute it, like you'd have to, and then this one here you would also times by x, y, which would make that 4 equals 15xy. So you get y is equal to 4 over 15x here. And then here you would have x equals y, 4 minus x. So you have x over 4 minus x equals y. This would have to equal this. It can be done, but I don't remember us having to do reciprocals in the book. Okay, anything else off of there? No? Anybody else have anything today? Whether it's out of your workbook or, no? Okay,